Computer instructions are normally stored in consecutive memory locations and are executed sequentially one at a time. The control reads an instruction from a specific address in memory and executes it. It then continues by reading the next instruction in the sequence and executes it, and so on. This type of instruction sequencing needs a counter to calculate the address of the next instruction after execution of the current instruction is completed. It is also necessary to provide a register in the control unit for storing the instruction code after it is read from memory. The computer needs processor registers for manipulating data and a register for holding a memory address. These requirements dictate the register configuration. The memory unit has a capacity of 4096 words and each word contains 16 bits. 12 bits of an instruction word are needed to specify the address of an operand. This leaves 3 bits for the operation, part of the instruction, and a bit to specify a direct or indirect address. The data register DR holds the operand read from memory. The accumulator AC register is a general purpose processing register. The instruction read from memory is placed in the instruction register IR. The temporary register TR is used for holding temporary data during the processing. The memory address register AR has 12 bits since this is the width of a memory address. The program counter PC also has 12 bits and it holds the address of the next instruction to be read from memory after the current instruction is executed. The PC goes through a counting sequence and causes the computer to read sequential instructions previously stored in the memory. Instruction words are read and executed in sequence unless a branch instruction is encountered. A branch instruction calls for a transfer to a non-consecutive instruction in the program. The address part of a branch instruction is transferred to PC to become the address of the next instruction. To read an instruction, the content of PC is taken as the address for memory and a memory and read cycle is initiated. PC is then incremented by 1 so it holds the address of the next instruction in sequence. Two registers are used for input and output. The input register INPR receives an 8-bit character from an input device. The output register OUTR holds an 8-bit character for an output device.